Hey math kids, today we're going to talk about arithmetic operations on polynomials, and let's just get started. So basically we're just going to add, subtract, and multiply. So I'm going to revisit this idea of the box representing multiple problems. So the box will be defined possibly slightly different in each problem, so make sure you read the directions on that. On this one, I'm going to define the box as addition, subtraction, and multiplication. So it's 3 problems in one. We're going to put a plus sign right here, and we just combine like terms. So x plus x is 2x, and then 1 plus negative 2 would be negative 1. And so that would be my addition answer. Then I'm going to go to the box, erase it, change it to a minus sign. And what I like to do first with minus is I distribute a negative, so I change these signs. So negative, positive. And then it just becomes a addition problem after that point. So x and negative x is actually 0, so I don't need to write anything. And then 1 plus 2 is 3. So the answer to that when we subtract is actually just 3. Alright, go back to this, erase this, and yellow. Okay, now we're going to do multiplication. Multiplication is just distribution. So we just need to multiply everything by everything else. So x times x, we get x times x, we get x squared. X minus 2, we get negative 2x. 1 times x is x, and 1 times negative 2 is negative 2. So we get x squared, it doesn't combine. These two can combine into negative x, and we still have our negative 2, and so that's our multiplication answer. Okay, let's do one more like that. So we're going to say 2x plus 5, our box, which is defined as addition, subtraction, and multiplication, and we'll do that. So we start with addition, which is just combining like terms. 2x, 3x becomes 5x, 5, negative 1 becomes 4, 5x plus 4. Subtraction, we want to change the signs on just the second part. So subtraction, this is now addition. So 2x, negative 3 would just be negative x, and then 5 and positive 1 would be 6. So I'm going to get rid of these now. Now we're going to do multiplication. And so we got multiplication here. 2x times 3x is 6x squared. 2x and negative 1, negative 2x. 5 in that is 15x. 5 in that is negative 5. Combine the like terms in the middle, so the ends don't combine, but negative 2x and 15 would be a positive 13x. And that would be it. Okay, then if you go to the next section on your homework, you have problems that are a little bit different. So you're going to say x squared plus 3x minus 5 box, and 2x squared plus 3x plus 2. This time the box is defined only as addition and subtraction. So if you want to do multiplication for fun, you can do it, but you're not required to. So when this is a plus sign, we just combine like terms. So we have x squared, 2x. X squared and 2x squared would be 3x squared. I don't know where I wrote a plus sign there. 3x squared. And then this one and this one would make 6x. And then this one and this one would be negative 3. Okay. For subtraction, we need to change all the signs. So that would be subtraction, subtraction, subtraction. Alright, now we just combine like terms again. So x squared, negative 2x squared would be negative x squared. 3x, negative 3x would cancel and go away, so I don't write anything. And then negative 5, negative 2 would be negative 7. Once again, it was only defined as addition and subtraction, so I don't need to do multiplication. So let's do one more of those. Okay, once again, it's just addition and subtraction. So addition, we just combine like terms. 2x squared, 5x squared gives us 7x squared. 3x, negative 6x, negative 3x. Negative 10, positive 1 is negative 9. Then for subtraction, we change all the signs on the second one only. And so we get 2x squared, negative 5x squared, so that's negative 3x squared. We have 3x, 6x, so that's 9x. Then we have negative 10, negative 1, so that's negative 11. We don't need to do multiplication, but we will move on to doing only multiplication. So in this next problem, we are only doing multiplication. And so we multiply from here to here, we get 4x squared. Multiply from here to here, negative x. Here to here, negative 20x. Here to here, positive 5. Combine the like terms in the middle, we get negative 21x, and everything else stays the same. Let's do one more of those. This time we have 7x plus 2 and x minus 5. Okay, 7x times x, 7x squared. 7x times negative 5, negative 35x. 2 times x, 2x. 2 times negative 5, negative 10. Combine the like terms in the middle, leave the other ones the same. So this would be negative 33x. And that's our multiplication. Now there's one more type of problem. So we are given a rectangle. It's broken into pieces. And we're given some of the lengths. And we're asked to find the area in two different ways. So the first way I'm going to do it, I'm just going to take the length times the width. So the length of this is actually 5x plus 6, because it's 5x and then 6 more. The height of this is 3x plus 1. 3x plus 1. To find the area, we just multiply those together. We distribute 15x squared, distribute 5x, distribute 18x, distribute 6. Combine like terms. Let's see, that's 5x plus 18, so 23x plus 6. So that's one way to express the area. Now the other way is to think of this like 4 separate rectangles, or 3 separate rectangles, and then add them together. So the length of this is 5x, the height is 3x plus 1, then we're going to add that to this rectangle, which would be 3x times 6. Then we're going to add that to a 1 times 6 rectangle. Once again, it's just the length is 5x, height is 3x plus 1. Length is 6, height is 3x. Length is 6, height is 1. So we took each rectangle, found the area, and then added it together. So now we just need to simplify. Multiply these together, we get a 6. Multiply these together, we get 18x. Multiply these together, we get 50. It's probably not a good color. It's going to get confusing with that other one. We'll do white. So we'll multiply this, we get 15x squared plus 5x. Combine like terms, we get 23x, we got our plus 6, 15x squared plus that. And so we see that we got the same answer both ways. If we look at this and this, it's the same. If you need additional help, please come to Math Lab and calculate.